Okay, problem number 6 on this April 2nd homework one. Another really good of an example of problem number 6. There's a ton of reading. It took me twice as long to read this problem as it did to do it. Pretty typical, these problem 6s, so don't get too hung up in them. A lot of times they look a lot worse than they really are. I know they're hard the first few times, but they're not really as bad as they seem if you can kind of get through all the words and all the reading. There's not a lot of math involved here. So this was when we had 2 treatments with survival rates. The first question says one can be administered as a as a pill, and one is an injection. Can we do it double blind? So double blind means is the researchers don't know, as well as the people in it. Clearly the researchers don't have to know, someone can give it to them, so that's the easy part. People don't think this can be double blind because you got a pill and a shot, but you could do it. It wouldn't be great fun, but you could give everyone in the experiment a pill and give everyone a shot. Half the people, the pill's going to be live and the shot's going to be a placebo, and for the other half, it's going to be the other way around. So you could do it as long as you give a placebo. Placebo shot wouldn't be great fun, I don't think, but you could do it. Second problem, part B, just says the conditions for inference have been met, so you have to do construct and interpret. Oh, I forgot to interpret. A 95% confidence interval, so just write on the calculator. Just proportion 1, proportion 2, it's a 2 proportion Z interval. I got from 6.73% to 23.1%, so the interpretation would be I am 95% sure that, I'm going to shorthand this a little bit since I forgot to write it, that the difference in rates, success rates, between A and B is somewhere between 6.7 and 23.1. You can see this one definitely looks better, but that's the difference in the rates. So then they have this new terminology that's often used in the science world. Actually, they don't use these rates, and we have to answer this question in E, so I'll explain a little bit more in E. They use what's called a relative risk rate. So they give you a whole bunch of reading that basically just divide the 2 rates is all it says. So part C says find the relative risk. It's just PA over PB, so it's just that number over that number, so it's 2.53. A lot of reading, not much to it. And then the rest of that just goes all these things about logarithms, blah, 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 blah. It's not really that important, to be honest with you. So you turn the page, and they said they did a 95% confidence interval for the natural log of PA over PB, just because they felt like that math was going to work better. And they got 0.38 to 1.46. And then they ask us to do the confidence interval for just PA over PB. So you just have to undo the natural log is all you got to do. So all that and all that is basically just a little bit of algebra you undo. You undo the natural logs by exponentiating, right? So e to the 0.38 and e to the 1.46. So I got 1.47 to 4.34. So that's the relative risk, 95% confidence interval. And then they say, what's the advantage for using this? This is a little bit weird. I don't know why they would ask this question because it's like outside knowledge. The idea is if you told someone that the success rate confidence interval was this to this, they're not going to exactly know what that means. We might, because we've learned it in the math class. But if you tell someone is 2.5 times better, or it's going to have a 2.5 times the success rate, people clue into that a little bit better. So mathematically, this number kind of makes a little bit more sense than that, especially as this number gets closer to 0, right? So if I said that the confidence interval was like 2% to 7%, would you say, is that one that much better? I don't really know. But if I threw that number at you and said 2.5 times better, it's a little bit more powerful for the lay person, for the non-math person to understand what that means. That's all they meant on that one, I think. So again, the number 6s can get a little hairy, a little long in the reading. They're all very, very different. You can see this one's way different than anything we've done, except this was the same. But not as bad as they look once you practice, practice, practice. I don't know if you're going to get a number 6 type problem. I'll talk to you more a little bit about the context of the AP test when I know more. Since you're only going to get a few questions, you might not get one like this. I doubt you would actually, but you might, because it takes the math that you've learned and shows that you can show how it works somewhere else instead of just regurgitating a problem you've seen before.